Итак, наш последний докладчик на сегодня с другой стороны земного шара.
From the other end of the globe, Patrick Higgins from DC. Patrick, what's the time at your place right now?
It is, what is the time? It's 10 past 6 in the morning. But most of my colleagues are on the West Coast, so it's actually 10 past 3 for them. So I'm lucky there.
Да, Патрик, это такое мужество выступать в такое время.
You are a truly courageous person to wake up so early for the presentation. I couldn't do that. Thank you.
Расскажи пару слов о себе.
A couple of things about yourself. Tell us, please, what you do, what your company does.
Yeah, so Gremlin is a software as a service company that focuses on making the internet more reliable for our customers and for the community at large. The way that we focus on that at the moment is through thinking about chaos engineering tooling and making the process of applying the practice of chaos engineering easier for companies to implement. And something that's more approachable, because previously it's been something that has been only available to big companies like Netflix and Amazon. And over the last few years, that's starting to change, and we hope to be part of that change.
Can you tell us, in the recent years, how much development there has been in chaos engineering? I mean, to which degree companies use the chaos engineering more these days?
Yeah, I'd say the two big differences that have happened is that you've started to see a proliferation of tooling, and that's both tooling that is coming from companies like commercial platforms like ours, and also open source tooling as well. It's something where cloud providers are also starting to think about how to introduce their customers to the prospect of chaos engineering. And a lot of that is about admitting that, or at least internalizing that a lot of these cloud providers will not have 100% uptime, nor will the dependencies that we use for different things, nor will they have 100% uptime. So how do we really reconcile with the fact that we don't live in a perfect world, and how can we improve the situation?
Well, go ahead, tell us more about this. Let's begin.
Cool. Okay, let's get into it. The first thing that I would like to talk about is just a few of a bit of history that I think many of the viewers will be somewhat familiar with. And if they're not familiar with these particular cases, I'm sure they'll be familiar with others that are very much like them. So the first one that I would like to bring up is the AWS outage in 2017 that affected S3. And this happened on the US East 1, in the US East 1 AZ. And essentially what happened there was that S3 went down and thousands of customers were affected. This was such a big outage that it impacted AWS's ability to update its own status page. So this was massive for a lot of internet-based companies and a lot of the tooling that we use as well. So organizations were affected like Docker Hub, GitHub, GitLab, Bitbucket, Travis CI, Slack, and PagerDuty. So these are companies that a lot of us use on a day-to-day basis. And it really, when any of these companies go down, it really affects our productivity and our ability to get things done. And this isn't limited to AWS. Also in 2019, Azure had a DNS outage that was caused by them looking to migrate some systems from a legacy system to Azure. And some of the DNS here was incorrectly configured in the process, and it took down a broad range of Microsoft products. It affected a lot of the Azure-related products and a lot of the services that Azure relies on as well. And also from Microsoft, we also had an outage in early 2019 that it was essentially like 2 outages in the same week that affected Office 365. So essentially, in the process of this outage, millions of users were affected. And this wasn't just people that work in the tech industry, it was people that work across a broad range of industries. There were customers of 365 that weren't able to access their email for over 12 hours, and some businesses had to close for the day. So you can see that the effect of this downtime can have massive economic implications. And in case you thought that Microsoft and AWS were going to be the organizations that were most problematic with downtime, it also happened to Google on June 2nd, 2019. And Google blamed high network congestion for this outage, and the outage effect had cascading implications to products like Nest thermostats, which is like a smart home product that would deal with climate control within your home. So homes were unable to control the climate within them. It also affected iCloud, YouTube, and Snapchat. So you can see that this outage has internet scale implications and millions of users are affected. And this isn't to really rag necessarily on cloud. Cloud is amazing. We are all benefiting from the fact that cloud is the new paradigm that we work within. But it is to say that failure is everywhere. You can pick a date and search for outage, and you're going to inherently find something. We work in systems that are complex, and failures are inherent in complex systems. So what do we mean by complex systems? Complex systems is a system composed of many components which interact with each other. So when we think about this, it's worth keeping in mind how complex systems can get. These are 2 images from Amazon and Netflix of essentially like their microservice infrastructure. And this is from 2015. So you can imagine that from 2015 to now, things have got more complex as they've gone. They must be some pretty incredible balls at this point. So this really like resembles or is a good kind of representation of the fact that we've kind of made the switch as an industry from thinking about things in an on-prem environment to thinking about the cloud. And this has implications. So good implications include decreased costs and lower maintenance as well. And also the ability to scale, whether that be in terms of teams and people or in terms of tech itself. There's also kind of trade-offs that we have to deal with, things that are more negative. So in terms of looking at infrastructure, one of the implications is that we have abstractions, and those abstractions create less control. So that's resulted in the need to think about new ways to build applications. We've also moved more from monoliths to microservices as things have grown, and this can have good implications as well. So we can be thinking about increased developer velocity as a result, and the ability to scale. But one of the trade-offs is that we end up with tens or hundreds or potentially thousands of microservices. So we end up with larger, more distributed, more complex systems. And we essentially need to think about new ways to test and handle failure. So we've been talking about downtime, and I think it's worth bringing up the potential ramifications of downtime. Downtime essentially costs us money. And we can break this down into quantifiable costs and unquantifiable costs. So the quantifiable costs include things like immediate losses, things like revenue. If you talk to your accounting or sales department, understanding the cost of downtime may be something that they are quite familiar with. And we also have the effect on employee productivity. So if employees are spending time firefighting or trying to remediate problems, they're spending less time proactively building to avoid those problems in the future. You also have the situation where you may have company chargebacks. So if you work in highly regulated industries such as finance, you may have government regulation that would lead to some kind of like fine or punitive measures that come from downtime, and you also have the potential for SLA breaches as well. You also have unquantifiable costs, which are things that you would not think about up front, but may have a huge ramification on your ability to make money as well. The first one is brand defamation. So if your product continually seems to be broken, customers may not want to use it or may become frustrated with this cost, with the downtime. You also have, particularly if you're a publicly traded company, sometimes the cost of downtime can be quite substantial. In 2017, British Airways had a huge outage, and it actually cost them a grand sum in stock of $75 trillion overnight. So it was a massive outage and huge financial implications for them as a company. You also have employee attrition as a knock-on effect. So if you're continually in a situation where you're having to wake up at 3 a.m. and you're continually fighting fires in terms of how you're interacting with your infrastructure, you may be in a situation where you start to look for a new company. And when that happens, when you start to look for a company where you can start really just work between 9 and 5, your former colleagues or the people that you have been working with have to bear responsibility for things that you would have been doing if you were working at the company. So essentially, when you leave, those activities, that labor is passed on to the people that you're working with. When that happens, there's more likelihood for them to get burnout as well, and for them to leave the company too, passing that compound effect onto other people. So you can see that if you're not dealing with failure and with downtime in a proactive way, this can turn into a tailspin for your employees. It's also worth noting, in terms of looking at quantifiable costs, that Amazon loses, they estimate about $220,000 per minute, and you may find that for the average e-commerce company, the effect is $300,000 per hour. So you can see that even for small companies, small e-commerce companies, or medium-sized e-commerce companies, there are huge ramifications. And then as you get bigger as a company, as you scale, those implications become bigger as you go. So if failure is inherent and it costs lots of money, what do we do? So I'd like to humbly suggest that chaos engineering may be a mechanism or a practice through which it can help you build more resilient systems and potentially avoid some incidents. It trains you as a team to identify incidents better as they happen, and also trains your team to respond to those incidents as well. So as we said before, my name's Patrick Higgins. My job title is Chaos Engineer at Gremlin. You can find me if you'd like to reach out at patrick@gremlin.com or at HiggyCodes on Twitter and GitHub as well. I am originally from Sydney, Australia. I moved to America in 2014. When I'm not kind of thinking about tech, I love playing and watching football, and really like cycling as well. They're two things that I'm really passionate about. And as we mentioned before, I work at Gremlin, which is a company focused on building more reliable software, and you can find them at gremlin.com. So what I want to do is go through kind of like what is chaos engineering, and then we can talk about chaos engineering as it applies to automation practices. So let's look initially at what chaos engineering is. So chaos engineering is a bit of a misnomer. It sounds like a very destructive name, and we're not really looking to be destructive. What we're looking to do is go through a process of discovery. What we're doing is simulating the chaos of the real world in a controlled environment and really looking to uncover chaos within our system through that process. So chaos engineering is carefully applying failures with an explicit hypothesis. So something that may be familiar to people from doing science in high school is the process of the scientific method. So starting with a hypothesis and going through the process of validating or disproving that hypothesis through performing experiments. We also want to think about starting with small increments that yield the smallest possible signal and moving from small-scale experimentation to larger-scale experimentation as we go incrementally. So this process may be, or should be, from moving from smaller targeting, smaller blast radius to larger blast radius, but also thinking about moving through different environments too, from dev to staging to production. It's also really important to think about chaos engineering as a collaborative practice. You want to share your plans with everyone, and you want to make sure that the experimentation that you go through does not affect other teams negatively. You also want to share what you learn so that your organization has a better picture or a more full understanding of the way that your system behaves. And you want to make this practice all about learning. So sharing the learnings that you have internally and also potentially externally with going through a process of discovery of what works for your company, and then being able to give back to the tech community, to be able to publicize that externally as well. So chaos engineering is about iteration too. Once you go through the process of creating a hypothesis and running an experiment, you want to create tasks to improve your software and your practices. Then you want to update your hypothesis and repeat this process. This is really similar to thinking about if you've ever lifted weights before. You don't want to start with the huge, very heavy weights initially. What you want to do is start with weights that are within the range of your capability. And then as you progress through a practice of continually applying weight training as a constant regime, you move into having the ability to lift heavier and heavier weights as you go. So all in all, to sum it up, chaos engineering is thoughtful, planned experiments designed to reveal weaknesses in your systems. These systems are both technical and human. So from a tech perspective, we want to ask the questions around what happens if things like the user experience is broken for customers coming to our particular product. We want to ask the questions around monitoring and alerting, and essentially looking into validating if those inferences are signaling in ways that we expect. We want to look into thinking about our auto-scaling configurations. Are they working as we'd expect as well? And then think about things at the application level. So do our retries function correctly? Do we have circuit breakers when we get into some kind of bad state? We also want to think about the human systems and the processes that we have as an organization. So these might be things such as alert rotation, thinking about the documentation and playbooks that we have for our employees, And then also going through a process of escalation. So if things need to be escalated up to hierarchy, making sure that that process is as we would expect it to be. So let's dive into thinking about setting up an experiment. So we think about setting up an experiment with two potential vectors. The first one is thinking about the blast radius, which is like thinking about the number of hosts or containers that you're looking to target with an experiment. And then you can also think about the magnitude of the attack you're running. So if I'm thinking about blast radius, I might say I want to target 3 nodes. If I'm thinking about magnitude, I might say I want to increase the CPU consumption by 20% across these 3 nodes, and I want to see what happens when I do that. And then you build a hypothesis around that specific action. A process that also gets used quite a lot with chaos engineering is the idea of game days. A game day is a dedicated time to come together to gain insights and build an opportunity to execute experiments together to prove or disprove the hypotheses that you've created and to test the resilience of your application and infrastructure. So it's really about this dedicated time. You want to be setting time aside so that you can do these things as a team. And that team could be really varied. It could be made up of people that come from a infrastructure background. It could be people that work in SRE. It could be application developers as well. It's even effective to bring people in that come from potentially design and product management, because if we bake dealing with failure into the product from the outset, and we're thinking about that as a potential possibility, we're going to build inherently more robust applications and essentially have more resilient and robust systems. So this all sounds very exciting. A new mechanism to deal with problems that we all deal with, massive headaches that we have working in cloud. But you may have some kind of like excuses or some kind of reasons for not doing it, and I want to go through a couple of those because I think they're important. The first one is that we don't have time. It's a very good reason. The nature of working in tech is that we never have enough time to get everything done. That is more and more true all the time. And really this leads us to a position where we need to prioritize. And this is all accurate, but at the same time, at some point, if we're going to have outages, we're going to be in situations where we have to be reactive and we have to firefight. So if that's the case, it's worth thinking about this a little bit like tech debt in that if you do not prioritize these things up front, if you don't prioritize looking into the way that your systems may react under specific conditions, essentially what you're doing is offloading that labor, that time you're going to spend to a position where you are reactively firefighting, and you're probably not going to be able to deal with these things in an effective way. So even though you may not necessarily be thinking about it as tech debt up front because you're not immediately aware of it, at some point it will come back and bite you. The second excuse is we don't need to break things, they break on their own. So really this kind of like leads into the first one, in that if your systems are breaking, which they may, and they may be doing it regularly, you really should ask yourself the question, do you want them to break at 3 a.m. when you're asleep, or would you rather look into uncovering this chaos in your own time, not at 3 a.m., potentially between the hours of 9 and 5? The third reason, which is a very good reason, is we don't know how to get started. And the response would be that it is good to think about starting simple. So asking questions, potentially questions about resource consumption. So is my infrastructure resilient to or robust or reactive when we're thinking about dealing with CPU pressure? Will it deal well with memory pressure? Does services restart if a process or container is killed? So you really want to ask these very basic questions and ask them about very small isolated parts of your system and perform those experiments on those parts and then build up from there. So what are the assumptions that I have about the way that my system works? I want to build hypotheses around these assumptions and then I want to validate them. So we have no more excuses. This is a good time to start, and it's a very good time to start because as we build more products, as we build and we grow, it tends to be that our systems become more complex over time, and building a practice of asking often about how these systems might fail allows us to really ingrain the process of making this a practice and asking that question continuously as an organization all the time. So let's talk about how to chaos engineer. How do we get started? So as we've been mentioning, the idea is to start small. We start with this initial test. When we have that initial test, if that goes well, if we've validated our hypothesis, that gives us the ability to scale up and think about expanding that blast radius. We want to be doing all of these actions in a very controlled environment. We want to do them with a team ready, and then we want to expand. We can also think about the vector of our environments. So we can adopt a practice thinking about doing it within development environments so that engineers are essentially architecting for failure before code is shipped. We can get more confident about testing in this development and then move into staging. We can start again, then small in staging, and then expand our blast radius as we go. Finally, we do have the ability to move into production. Again, we would want to start very small and increase as we go, keeping in mind that that we don't want to cause downtime at the production level. This is obviously very simple to thinking about code development and code promotion. You know, this particular pattern should be familiar to all of us. So don't overthink about it. Don't overthink it. Think about things in very simple terms and work iteratively like you would with code. We get asked a lot at Gremlin by people interested in chaos engineering, is it worth chaos engineering if we're not going to do it in production? And generally speaking, it is actually quite useful to do chaos engineering in environments outside of production. There can be a lot learned from doing so. But at some stage, the question needs to be asked about where your customers are. And I think this quote is very useful. Without production testing, recovery won't work when called upon. So it's worth mentioning that regardless of what we do in replica environments that mimic production, no two environments are the same. Staging is not production, and it's not where your users are. So if you're not experimenting in production, there's no guarantee that the safeguards that you're building in other environments will actually replicate correctly. Testing in production does sound scary, and if you go about it irresponsibly, it is. It's essentially got to be something where you apply a lot of diligence to it, and essentially you want to build up that confidence in the other environments before you promote to production. So we think about, we've talked a lot about targeting. and I think it's worth bringing up what kinds of experiments, what kinds of entropy we can add to our system, and a lot around what vectors we should be thinking about it. So the first ones are resource failures. So they may include CPU consumption, disk consumption, memory consumption, and I/O. Obviously, this is kind of like what the cloud was built for. It was built for thinking about what we do to scale when our resources are consumed. So really what we want to do is validate that those things are working correctly. We also have service level failures. So they're things like thinking about killing processes, shutting down hosts, pods, or containers, and potentially skewing clocks as well. So thinking about what happens potentially when certificates expire is actually a really good experiment that we can do using a time travel experiment. We also have dependency failures. So thinking about things like what happens at the network level. So we can essentially look to black hole particular services. We can also perform attacks on our DNS, which can be incredibly useful, given that DNS is traditionally very, very hard to deal with. We can also think about injecting latency and see what happens when we do so. And then think about packet loss as well. You know, the network is not perfect. We're working in a cloud environment which is highly dependent on network availability. So what happens when this is removed? What happens if things aren't working correctly? And what happens if there's some, you know, massive physical outage where you know, some cable somewhere gets broken because of, you know, road maintenance or whatever it may be. Once we've applied this kind of like experimentation to the infrastructure level, it's also worth thinking about the application level. So what happens when we test at the application level, potentially injecting latency or throwing exceptions or increasing memory consumption at the application level? Will this affect my monitoring correctly? Will my logging show that these things have happened? Do we have the proper timeouts and retries as well? And after we've kind of applied all these kind of experiments, the next step is to think about continuous chaos. So once I have confidence in certain aspects of my system, making sure that in an environment where complex systems continually change and are quite dynamic, how can we automate those experiments to make sure that we don't regress and drift into failure? And so that kind of segues into thinking about automation generally. And some of the ways that we think about automation are through status checks, scheduling, API calls, and SDK implementations, and then thinking about CI/CD and, generally speaking, code promotion as well. So the first one to bring up is status checks. And essentially what we're trying to do with status checks is think about ways to automate creating guardrails for our experimentation and making sure that we're experimenting as safely as possible. Status checks allow us to essentially check the health of a system before, during, or after chaos engineering experimentation. And the way that we do so is to connect our experiment itself with some kind of feedback mechanism, whether it be some kind of monitoring or alerting tool, to make sure that if we end up in a state that we consider to be a part of our halting criteria, like we've decided that the experiment has reached the point at which it may have some kind of like ramification that we're not comfortable with, then we essentially want to be able to halt that experiment immediately. This essentially automates that process of halting the attack so that we don't have to think about the process of doing so manually. And it's also worth bringing up that halting generally should be something that is quite easy to do with chaos experimentation. If you can't roll back the effect of a experiment, you're essentially experimenting dangerously and you don't have control of the situation. So status checks give us a very effective mechanism for halting that experimentation. We also want to think about scheduling. So configuring experimentation in advance. This may be a situation where we have we've already performed an experiment, and then what we want to see is we want to make sure that under the varying conditions that we are working within, that experiment is working continuously in a way that we expect and that we're comfortable with. Often it's good to think about running these attacks specifically between 9 and 5 in situations where we have the ability to monitor the situation, to know that they're going on, and if these are doing things like validating our monitoring tooling, validating our alerting. We don't want to be scheduling attacks for 3 a.m. in the morning when our SRE team may have to deal with that. We're not going to make friends that way. So it's very important to think about that when thinking about scheduling. You may want to schedule in the future at an exact time or within a potential time frame too. And thinking about API and SDK implementations. This is something that I'm quite passionate about. I think it's really important. And it's about kind of starting to think about experimentation and chaos engineering configuration as code. It also gives us the ability to start thinking about the ways that people interact with various tooling associated with chaos engineering. So a good example may be that you can allow application developers to start running experiments that are run from your developer tooling, for example. You may have internal tools that allow you to configure attacks quickly that are specific for your use cases as well. And we also have the ability to think about CI/CD tooling. So adding chaos experimentation to your pipelines. This means that as we move through validating the checks on our code, chaos engineering experimentation can be part of that check as well. And essentially an external mechanism outside thinking about end-to-end testing in a traditional sense. So in this way, we could spin up an environment. We could perform experimentation against our applications and our infrastructure. We could look into how that is affecting things based on the monitoring and alerting and observability tooling that we have associated with that build. And then from that position, we can look to see if the code changes that we're making are sufficiently robust for the external pressures and real world situations that they're going to face once they hit production. So automation sounds great, but I think it's worth kind of identifying exactly why automation is very useful and why it's important to do. So the reasons that I'd like to highlight are that it prevents regression, as we've just mentioned, particularly with CI/CD and thinking about scheduling. It prevents human error, so we're not going to fat finger or misconfigure experimentation that we're doing on a regular basis. We also want to think about reducing time spent manually running tests. And we also want to think about reducing toil as well. So what is toil? Toil is the kind of work that is tied to running production services that tends to be manual, repetitive, automatable, tactical, and devoid of enduring value. So what does this mean? It means that it's kind of like those repetitive processes that you go through regularly, where they're things that you should, they're things that that are more like, they're physical, right? They're not things we're putting brain power into, and they're things that we should really think about automating. When we say tactical, what that means is that we're thinking about things reactively. So we're thinking about the fact that I've got to, I've got this task in front of me, and I just need to complete it. I'm not thinking, I've got this task in front of me, and I see a lot of tasks like this in the future, so I'm going to make sure that I just do it once, automate it correctly, and then take it from there. It's not thinking strategic, it's thinking about things in a very reactive sense. It also has, it also doesn't scale. So thinking about these things, thinking about reactive activities, they're essentially things where we're not thinking future first about the way that we're going to address this problem in the future. And so the consequences of toil are quite substantial. So toil is actually really destructive and something that we should look out for. It can lead to discontent and a lack of feeling accomplished with the work we're doing. It can lead to burnout. It can lead to more errors and more time-consuming rework when we're looking to fix things in the future. It essentially leads to not having the time to learn new skills, and this can kind of lead to career stagnation as well, which is something we should all try to avoid. So I just wanted to uncover for a second like how we'd think about injecting chaos experimentation into a pipeline. For this specific example, I just wanted to show you what we'd look at from looking at using Jenkins with Gremlin and establishing a chaos engineering stage as part of a pipeline promotion. So the first thing that I could do is go into the Gremlin application, and essentially what I could do here is configure an attack. And this may be an attack that is performed on the resource, state, or network kind of vectors. And what I want to do is configure that attack, kind of specify targets that I'm looking for. And when I'm happy with the configuration that I've got, I could export that attack using a curl command or using, or kind of exporting a HTTP configuration as well. Once I've done this, I could add that curl command to a step in my pipeline script in Jenkins. And that step would exist within a particular stage. So the step would be to run a chaos experiment, and then and that stage would that step would exist within potentially like a range of tests that we'd want to do, a range of experimentation, and would essentially want to validate after each experiment automatically if the code promotion that we're going through is making sense, is as robust as we expect it to be, and we'd kind of like situate that within this stage of the pipeline, so a failure injection stage. And so we want to be thinking about this as part of this process of thinking about creating an environment, installing our application into the environment, and then looking at the failure injection for that. If things aren't going as we expect, we can make it so that we have acceptance criteria, and that we want to perform this with the idea of not promoting this code as a possibility. So if you think this is cool and exciting, and you want to try chaos engineering for yourself, and you want to do it, and you want it to be specifically easy, you can go to go.gremlin.com and sign up -free and get started today. There's also a Slack worth mentioning for Gremlin. It's not specifically related to Gremlin, but more of a community Slack, and you may find a lot of interesting information there too. So thank you very much for having me today, and I'm sorry my voice is a little scratchy, but it's been an absolute pleasure to be on.